everyone. Thanks for coming to Andes RISC-V Con. So we all know that RISC-V is on fire. In fact, firing in all its cylinder. So in today's talk, I'm going to give, looking into a couple examples of Andes' latest customers' application in RISC-V, and take this opportunity to update a few of our new product offering for application processor, and vector processing, and also custom extension. So some background about Andes technology for those who are new to Andes. So Andes is a RISC-V Foundation founding member, and also a RISC-V International Premium member since 2016. So we sit on the board of directors and also a technical steering committee, and our members serve as chair or co-chair for task groups, and also ambassador. So here are some quick facts. Andes is a pure-play CPU IP vendor for 18 years. We never change our course. We have over 300 customers licensing our core, and we have over 400 people worldwide. And our Andes IDE has over 80,000 users busy developing their application. And together, our customers ship over 12 billion SoC with Andes embedded. So our headquarters is in Hsinchu, Taiwan, and with office in China and US, and also sales representative in Japan, Korea, Europe, and Israel. So some quick overview of Andes product lineup. So on the bottom, we have a compact series, two-stage, three-stage pipeline, and going up 25 series, five-stage pipeline with fast and compact processor. And going up, we have 27 series with adding MPUs technology for those who are sensitive to memory bandwidth and also latency. And going up, 45 series with 8-stage pipeline, superscalar. And on top, we have latest X60 series, which is a 13-stage pipeline out of order running Linux multi-core. So together, they form different application segments, from embedded control to compute acceleration to running Linux application. And recently, we also introduced a functional safety product line. So a couple of code here worthwhile mentioning. So our D25F is the first RISC-V processor with DSP capability, which is based on RISC-V's P extension for the CPU register-based SIMD. And NX27V is the first RISC-V commercial vector processor out there, starting with 512-bit vector width and also the processing width. And 25F SE is the first RISC-V fully compliant ISO 26262 processor on the market. So yeah, so this is kind of our lineup. And people are kind of wondering where is the RISC-V being used in the marketplace. So this is our application, or application by our customer. So, so basically from endpoint, edge, virtual cloud, to actual space. In the mobile space, we have customers using our processor for Bluetooth, Wi-Fi, touchscreen controller, storage, SD card, so on. And in the cloud space, we actually had quite a few customers using our vector processor for the data center AI accelerator. So there's a couple of them. We're going to talk into some of the detail in some of the categories, especially for those which disclosed very recently. First, in AIoT, we have two cases here. So Renesas voice control solution using 100 megahertz ASSP with our 32-bit DSP-capable D25F, which can speed up the application by over 50% with the DSP instruction compared to without the SIMD DSP. And Renesas also leverage our tight partnership with Cyberon, Opstar, and Sega to cover the voice recognition technology, and also doing the system integration, as well as providing the embedded tool chain for customers to do further development. And ASUS IoT Tinker 5 single board computer is based on Renesas RZ5 1 GHz SoC with Andes 64-bit X 45 MP. It supports Linux distro such as Debian and Yocto, and with rich connectivity. And it's ideal for industrial IoT and gateway applications. So Phison's the X1 is the enterprise storage. It leverages many of NX25F with Andes custom extension, and is used to creating custom instruction so that they can have very efficient interaction with their SoC components. And it's for AI, high-performance computing, hyperscaler data center use for storage. And 8-speed AST1230 is a multi-cam panorama image processor. It's also based on N25F, and it's used to create 8K, 2K real-time 360-degree camera with rich audio processing. So their application is for immersive applications, such as video conferencing, virtual factory inspection audit, online shopping, touring, and so on. So Picocam PC80X using 32 and N25F construct as a couple RISC-V cluster, and also another core to running Linux, and to serve the 5G small cell and to run Open RAN. So it uses the RISC-V core to achieve low power and flexible embedded control for tasks like scheduling, resource management, and also assist computation for digital front end and pre-distortion. And it also, because so many cores do to enable the programmability, it can support basically future-proof for the protocol and interface upgrade for Open RAN. And all the above is supported by friendly development environment, either running on Zephyr or Linux for application development. So Homo H30 is an AI accelerator using computing memory, or CIM. So the SoC has a large array of tiles, and each tile contains our NX27V, a vector processor, a fixed functional unit, and some shared memory, and also a tensor engine, where tensor engine is an array of SRAM-based CIM. So their CIM is has all the standard SRAM stuff like one-line driver, storage in the W cell, and then added multiplier, adder tree, and accumulator to form the matrix multiplication operation. So together in the whole chip, the CIM maker can provide 256 TOPS with the INT8 format. And NX27V vector processor provides flexibility to tackle the long tail problem as when the AI algorithms continue to evolve. And each provide 128 GOPS through a versatile RISC-V vector instruction extension. And they also utilize NX27V's ACE interface to simplify the custom instruction extension, where they use that custom instruction to create the tight couple with the rest of the tile through the interface we call ASP, Andes Streaming Port. So we also have another customer, Tetraman, and their technology is also in compute memory. I think in the booth you can find they have a pretty interesting wafer demonstration there. So we are looking forward to their final product with RISC-V embedded. So Lightelligence is an optical computing company. They has multiple MEC to process the data and to lower the total cost of ownership. And it is said to have kind of 100x performance over the GPU. And they also use the optical to do the NOC, to share the data, reduce the latency. They are designing an AI accelerator using photonics, where they contain multiple custom and digital coprocessor, and contain at least one photonic coprocessor. And they also use multiple Andes RISC-V processor, which has powerful 14-point instruction, can operate multiple in parallel. And also using Andes custom extension. One of the examples, recently we have a joint webinar with them and also in Paris. They talk about using Andes custom extension to create a mailbox to do SoC control. Okay, just one more accelerator, Meta Training Inference Accelerator. So Meta just report this paper, MTIA first generation silicon targeting meta recommendation system 10 days ago in ISCA 2023. So the SoC essentially has an 8x8 processing element array, so 64 of them. And each processing element has some fixed function unit controlling the memory movement, dot product computation, and also common function like exponential and also hyperbolic tangent. And also there's two RISC-V processor, processor A and processor B. One is scalar, the other one is vector. And it is used basically the two configuration of Andes X25-V100. So this is kind of weird name, but this is an early version of the popular NX27V. And they use custom extension heavily to create new interfaces, new instruction, and register to kind of make all the workflow in the PE very smooth. So this is a very good paper. So I just downloaded yesterday, so I encourage everyone interested in the machine learning to check it out. So I just give a kind of quick summary at the end. So it performed quite well and on the low and medium complexity models compared to GPU. And for the high complexity model, as one benchmark there, there's still room to improve there. But I think they're on the way to kind of continue to do that in terms of tuning the software and also kind of think about the next generation architecture. Okay, and Andes is also driving innovation with the core I talked about earlier, NX25-SE, which is industry first RISC-V ISO 2622 fully compliant core. So we got the certification from HGS Tube last October, and today we already have close to 10 different customer applications. So here is a precise customer application here. We categorize into 5 different types. But this is not possible without a partner to supporting us for the compiler, tools, RTOS, and AutoSAR. So my colleague Samuel in the afternoon session going to diving more into our auto solution. So enough about kind of existing applications. So what going forward? So we have the high-end processor, X65 auto-order application processor. It's a 13-stage 4-way 64-bit auto-order processor. It's supporting RVA22 profile. It's multiple cluster, can go up to 8-core, 8 executing pipeline with 4 integer, 4 ALU, and 1 pipe can do the branch. And we have 2 full load store. That means you can do 2 load, 2 store, or 1 load, 1 store in parallel when you issue it. And 2 floating point. One has all the floating point instruction. The other one just lack of the less use divide and square root. It had 2 level BTB with a Tage branch predictor and a loop prediction. it only had 2-level cache. So private cache is IND 64K, or 4-way and 4-bank, so that it can sustain multiple low store access, and also when this instruction fetch goes to end of line, actually you can exit the next line at the same time. And share cache is up to 8 kilobytes, 16 weight. And it had all the major buses for memory, MMIO, and also IO coherent port is 256 bits. So its performance using TSMC 7 nanometer without overdrive, it can get to 2.5 gigahertz. And spec in 2006 is 8.25 per gigahertz, and spec FP is 10.2 gigahertz. So as far as I know, this is the best spec 2006 with only 2-level cache. So actually the performance even better than some of the core with 3-level cache. So what's ahead of the X60 series? So X65 started with the series. So we're going to have X66 to support multi-cluster, and going up X67 will support RVA24, and it will be most performant. So RVA24 is set by Google to be fully aligned with Android. So we kind of have high expectation on that. But in parallel, we also kind of working with a partner at porting the Android to the existing platform. And on the far end, X63 would be power and area optimized. So it's pretty kind of open now, kind of depending on our discussion with customers to see what kind of corner they want to kind of optimize to, because there's also kind of performance requirement to complete the equation. Okay, so next, X45 MPV, multi-core cluster. At a multi-core cluster level is very similar to X65. So it's up to 8 core, you know, to cache, similar size up to 8 megabyte. And XY bus interfaces go up to 512 bit to support the vector access. So its SCADA unit support RVA, GC, BP, and also able to run in Linux. It's a 8-stage pipeline in order issue. So this is SCADA part is very similar. So the interesting part is the vector processor part, vector unit part. It support RVA 1.0 with some of our extension. For example, in the RISC-V standard data format, we support int8 to int64 and 14 point, FP16 to FP64. And we also support int4 as well as bflow 16. And for the hardware configuration, the VLAN and DLAN, we support the range from 128 to 1024 bits, and with 1:1 or 2:1 ratio. And even though it's a dual issue, but because the RISC-V vector has this LMA option, LMA runtime setting so that the vector can run in longer. So even though we are dual issue, and at the peak time we can generate up to 6 DLAN results per cycle. Okay. So now before we talk further, I want to acknowledge that the AI accelerator we talked about earlier actually has a common architecture from very high level, as we can see it. It's scalable. It's with a separate decision for control and compute processor. So it's a control processor, basically one in the SoC running OS application and orchestra the cluster. The cluster has one or more processing element. Inside the processing element, there are hardware acceleration unit with fixed functional unit, DMA, and SRAM. And the compute processor, certainly RISC-V vector processor is the ideal option. And you also need to have a high bandwidth memory subsystem so that it can communicate with the rest of the system. But the most important thing is how do you efficiently exchange the data and do the control for the hardware engine. So for 45MP, it supports 2 solutions for the tightly coupled hardware engine. We already see that streaming port through ACE. It's basically a wide data port allows to transfer data between vector register and hardware accelerator, basically from its SRAM. And also command bus are used to control the hardware engine, because hardware engine has a lot of fixed functions that require the control. And together using ACE, you can generate custom instruction to operate on these two buses. And another solution that we offer on 45 MPV is called HVM, a high-speed vector memory, which is on the CPU side. We provide a DLAN wide low-store interfaces with dynamic wait cycle. And in the HVM module itself, it's something which can serve multiple simultaneous access to multi-bank SRAM. But it's optional, because that interface going out can direct connect to hardware engine interface if they can adapt our same interface, and that HVM module can be the SRAM inside the hardware engine. So both can be used at the same time, and you can achieve up to 2x DLAN cycle two DLAN per cycle bandwidth writing to a vector memory, a vector register. So we talked a lot about the Andes custom extension. So it's basically our automatic framework to create instruction to speed up computation and control. Custom can writing just attribute to tell the tool called compiler to generate custom register, custom memory, and custom port with arbitrary number and width, and then you can use those as your operand to your instruction and automatically generate all the required components to your RTL simulator and all the tool. And we extend that to support RBV type style instruction. So basically, if you look at the right figure, basically it's part of the vector processor, vector unit inside the, for example, 45 MPV. And essentially, you're adding the empty function unit inside the VPU with all the interfaces connect to it. So it has a feature of, for example, in the operand side, you can have 2 read or 1 write of the vector register file. And also you can read from the integer register or 14-point register or immediate. And the operation to perform can be ELAN based. That means all the ELAN have the same operation, so you just need to define it once, and we can our tool will replicate it for you. Or we give you the whole DLAN of data, it can do everything, cross-LAN operation and so on. And optionally, you can do narrowing and widening, and instruction can be maskable. We also provide the UVN environment to help custom logic, that is the functionality itself for the debugging. And so, in addition to what we mentioned earlier, so it also automatically generates the decoding, the formatting of the instruction, like widening or narrowing, and dependency checking, and data forwarding, or we call chaining for vector. And the instruction itself is RVV control aware. That is understand LMR, SEW, and VLAN, and so on. But that's kind of controlled by the upper level code, which we generate automatically. So for example, you can define a complex number, let's say multiply accumulate. So you can define a data type as AP32, but actually you get 2 AP16 number, and then once you get the input to your function, to your SRVV function unit, it can perform whatever operation you want. You can do that for metric complex number multiplication. Or you can do, for example, take 2 32-bit data as a unit, and then the output can be 2 UINT, that means 64-bit is widening the data. So it's quite sophisticated. Okay, so last but not least, so RISC-V continues to rise rapidly. So everyone knows what RISC is now. So as far as we see, more and more applications are powered by RISC-V. Take Andes as example. Our first RISC-V core, N25F, which we designed 6 years ago, still got a lot of custom traction. think it has all the potential to become ARM9 of RISC-V. And complexity of AI machine learning model keep growing. So our Andes27V plus ACE empower initial RISC-V cloud AI accelerator, and 45 MPV and ACE would take it to the next level. But at the same time, 45 MPV support Linux and multi-core, so you can bring the power AI solution to the edge and make it much easier to program. And in addition, Android, AR, VR, automotive, and more are looking for RISC-V appealing processor. So with our X60 series, starting from X65, we aim to address the demand. So more coming in the afternoon by my colleague Samuel to cover the complex secure core full SaaS solution and also more AI support for the edge. So with that, I conclude my talk. Thank you.
Thank you, Dr. Su.